For more videos like this for Compact 211, you can check out Sarai Studies. Link is in the description box below. Method 1 starts with the number that they give you and you divide it by 2. That's 7, 14, 1, bring down the 6, that's 8, 16, 0. So your answer is 78 with a remainder of 0. Then you take 78 and you divide by 2. So this is 3, this is 6, this is 1, bring down the 8, this is 9, this is 18, this is 0. Your answer is 39 with a remainder of 0. Then you take 39 and divide it by 2. So that's 1, that's 2, that's 1, that's 9, that's 9, that's 18, that's 1. So your answer is 19 with a remainder of 1. Then you take 19 and divide it by 2. This is 9, this is 18, 1. So your answer is 9 with a remainder of 1. Then you take 9 and divide it by 2. So it's 4, 8, 1. So your answer is 4 with a remainder of 1. Then you take 4 and divide it by 2, and that's 2 with a remainder of 0. Then you take 2 and divide it by 2, that's 1 with a remainder of 0. And then you take 1 and divide it by 2. So remember that the rule when it comes to remainder is that once the numerator is smaller than the denominator, the remainder will end up just being the numerator, 1, and your answer will be 0. In other words, you stop because you'll get to 0, and once you get to 0, you need to stop. Now, what does this tell me? Well, our remainders are bits. If you count them, I have 1, 2, 3, 4, 5, 6, 7, 8. That means I'll need 8 bits. And then we're starting on this side. If you ever forget, just remember the right side is the right side to start from. If this is the first number you see, then because you're starting from the right side, that's the first number you're going to put down here. So this 0 is going to be put right there. Then this 0 is going to be put right there. Then this 1 is going to be put right here. This one's going to be here. This one's going to be there. This 0 is going to be here. This 0 is going to be there. And then this one is going to be there. And this is 156 in base 2 in binary. So that's one way to do it. The second method requires you to know how many bits you need to represent this decimal number. So how do you figure that out? Well, I like to do this table. So you're in binary. It's in the name. Bi means 2. Your whole world in binary is 2. So we're going to start off with powers of 2. And if you're a programmer, you know that we start counting 0. So we'll do 2 to the 0 power, then 2 to the first power, then 2 to the second power, and so on. Then we figure out what those powers are. What is 2 to the 0 power? Well, anything to the 0 power is just 1. 2 to the first power is just 2. 2 to the second power is 4. 2 to the third power is 8, and so on. Then all you have to do is subtract 1 from these. So 1 minus 1 is 0. 2 minus 1 is 1. 4 minus 1 is 3. 8 minus 1 is 7, and so on. Now you don't even need this. You just needed this to get to these numbers. So to figure out how many bits you need to represent the number 156, all you do is locate 156 in this range. Where is 156? Well, it's between 127 and 255. And the way you read this table is you say, if I have 7 bits, then I can represent up until the number 127. But that's not enough to represent 156. So you move on to the next. If I have 8 bits, then I can represent all of the numbers up until 255, which includes 156. So in order to represent 156 in binary, I need at least 8 bits. And I say at least because you could do 9 bits. You just won't need that 9th bit, so you'll just have a 0 in that place value. But you need at least 8 bits. So now we know that we need 8 bits. So what the professor can't do is say, hey, represent 156 only using 4 bits. That's impossible because if you only have 4 bits, then you can only represent up until the number 15. That's nowhere near 156. You need at least 8 bits to represent the number 156. Now, as always, set up your powers of 2. Remember that the right side is the right side to start from. So we'll have 2 in each of the digits. As programmers, we start counting by 0. So 0, 1, 2, 3, 4, 5, 6, 7. We know 2 to the 0 is 1. 2 to the first power is 2. 2 to the second is 4. 2 to the third is 8, and so on. So you'll have the powers of 2. Now remember, the default is that the right side is the right side to start on. So we start here and we move our way down here. As we set up our powers, we start here and we fill in our bits this way. That's the default. So you're always going to start on the right, except for when you're doing method 2. So in method 2, the algorithm works when we start on this side and we fill in our bits this way. You take your number that's given to you, 156, and you ask yourself, is 128 less than or equal to this number 156? Yes. So 1 for yes, and then you subtract this number 128. that gives you 28. So we have a 1 here, and our new result is 28. Then you keep going. Is 64 less than or equal to this new result, 28? No. So 0 for no, and you keep going. Is 32 less than or equal to 28? No. So 0 for no, and you keep going. Is 16 less than or equal to 28? Yes. So 1 for yes, and then you subtract 16 from 28. So that's going to give you 12. So your new result is 12, and you keep going. Is 8 less than or equal to the result, 12? Yes. So 1 for yes, and then you subtract 8. That's going to give you 4. So your new result is 4. Is 4 less than or equal to the result? That's 4. Yes, it's equal to. So 1 for yes, and then you subtract 4, and you get 0. Once you get 0, you're done. Everything else after that is just 0. And this is 156 in base 2 in binary. Notice how they are the exact same thing. Here I have a 0, so there's a 0. Here I have a 0, there's a 0. Here I have a 1, so there's a 1, and so on. There's 2 different methods to go from decimal to binary. And if on an exam you're not sure if this is the right answer, or maybe you just forgot to start from the left when it comes to method 2, you can always check your answer, because you can always just take this from binary and convert it back to decimal and see if it actually is 156.